You've probably heard about linked lists. Today we'll cover what they actually are, the difference between singly and doubly linked, where they show up in real systems, two classic problems, reversing a linked list and merging two sorted lists, and finally, when you should actually pick a linked list over an array. A singly linked list is a chain of nodes. Each node holds a value and a pointer to the next node. The first node is called the head, and the last node's pointer is none. That's how we know we've hit the end. Unlike an array, the nodes aren't sitting next to each other in memory. They can be anywhere, the pointers stitch them together. A doubly linked list adds one more pointer per node, going backward. Now each node knows both its next and its previous neighbor. You can walk the list in either direction, which makes removing a node easier. You have direct access to the one before it. The cost is one extra pointer per node, so roughly 50% more memory overhead. Linked lists show up in more places than you'd think. Your browser's back and forward history is a doubly linked list. Undo and redo in editors works the same way. Music players use them for playlists, where each song knows the next. Hash tables use linked lists to handle collisions, chaining entries that hash to the same bucket. And LRU caches use doubly linked lists for O of 1 eviction. To reverse a linked list, we walk through it once, flipping each node's next pointer to point backward. We keep three references, previous, current, and the original next, so we don't lose it after the flip. When we reach the end, previous is the new head. Constant extra space, linear time. This is one of the most asked interview questions out there. Merging two sorted linked lists is even more elegant. We use a dummy head node to avoid edge cases, that way we always have a previous pointer to attach to. Walk both lists with two pointers, whichever has the smaller value gets spliced onto our tail. When one list runs out, attach what's left of the other. Dummy.next is the new head. So when should you actually reach for a linked list? Use one when you're inserting or removing at the front a lot, that's constant time, while an array has to shift everything. Use one when the size is unpredictable and you want to avoid resizing. Avoid them when you need random access by index, that's linear, not constant. And avoid them when cache performance matters, because the nodes are scattered across memory. Linked lists are deceptively simple, but they're the foundation for so many other structures, stacks, queues, hash table buckets, even some forms of graph representation. Master them, and the next data structures get a lot easier. Next up, hash maps, and why they're basically magic.